So my name is Thomas Rennert. I was the local project leader for our very young MPCC implementation in Halle in Germany. Young, I mean we went live with the software in May 2008 this year, but we started with RIP reduction already in the beginning of this year. So first of all, I want to clarify, why do we need transformers? And this is a very simple picture here. That means in the near of power plants, transformers are transforming the power from a low voltage form to a high voltage form for the power transmission over long distances to the substations, and then back again from this high voltage form to the low voltage form to deliver the energy to the customers. And that means low voltage means low current, high voltage means low current, and these means low resistances, low losses. It's just for economic transportation over the wires of the grid. So who are we? I will just especially talk about one business unit, power products, and here especially about power products transformer service. And in transformer service, we are one of the largest players worldwide. We have 25 service centers. For example, the service center for North America is located in St. Louis. And for South America, for example, in Brazil, and Guarulhos. So my Portuguese is not the best. And also Halle is one of the key players in this ABB team. It means not only because of the amount of revenues, but also because we are the pilot in the MPCC implementation in the service part of the transformer service. And after our successful implementation, also the other factories will follow us. So when we're talking about the stress portfolio, what is scope of our MPCC implementation? Then it's the factory repair and the trafo site repair, which means factory repair. In the factory, we perform all services on transformers up to 1,100 MVA, 525 kV, and we have a lifting capability of 500 tons. Repair can be. Also, a product from us is just to produce the winding blocks and to transport them in vessels, for example, to other ABB companies. And we can also perform all services on site, which means we are bringing our factory on site. That means in our temporary on-site tents, we can also assure the same quality. To understand our process, I draw a small picture. So I just want to explain it and to show maybe the challenges per process step. So what we are doing normally, we are doing a quotation for the investigation part and the service part of a transformer to the customer. Then the transformer comes in, and we start to investigate. It means we are performing an electrical incoming test. Then we disassemble the transformer, we investigate them electrical and on the mechanical parts, and after this disassembly, we are doing an updated quotation, because now we have seen the transformer, investigate them, and so let's say this complete process step can take from 1 to 6 weeks. Then we are making this updated quotation to the customer, and then there's a certain customer decision process. That means till the customer comes back with the order for the repair. This is very difficult because sometimes when insurances are involved in this customer decision process, then it can take very long. And during that time, the transformer is disassembled in our factory and blocks our material flow. So it's really challenging. We have to focus to decrease this customer decision process. So then we are getting the order, and we're starting with the engineering. And then it depends. If it's an ABB transformer, then we have the design available. Or it's a non-ABB design from Siemens, for example, then we have to do a complete re-engineering. And so this can take from 1 week up to 3 months. So, and during this engineering, we have to order the materials, and this is very, very special. We have to say we have a lot of, or the most of the materials which are critical for the lead time, we have to order bounded. That means we cannot have them on stock. So, for example, bushings I've showed you, they on the high voltage side they can have a delivery time of 1 year. So we are really impacted by this material parts in our cycle time. And at the moment in the growing market, also the suppliers for components are really fully booked, and this is a challenge. So and then we have the production where we assemble the transformer, we are testing and shipping them. So it means we're producing the windings, we overhaul the tank, we're preparing the old core, we are doing the active part assembly, the final assembly, we are putting the active part in the tank, and then we test them and make them ready for shipping. As I said, our chances is the overall global service market. It means the need for energy is as high as ever, and we are looking forward to a very aging transformer population. I think the average is 30 years old transformers, so the risk for power outage is very high, and this is a good opportunity. We are the first large factory in our market who are focusing exclusively on service within the ABB. So we have the chance now to develop products on the sales side which are really value added for the customer, like on-site testing or fleet screening, for example. And when we talk about repairs, an alternative to repair is always to buy a new transformer. And here we have the you can say that a repair is often 30% faster and also less expensive than a new one. So, and speed in our market is a main advantage, especially for industry customers. AJ said this example, when an aluminium fabric losing the transformer and losing per day millions, then cycle time is here really very important. But also for the power utilities who have really a schedule where they close their grids. So also here the cycle time very important. The challenge we have in Halle, since we are ABB, we had the new and service business in parallel. But in this year we will work on our last new transformer, and then we will just focus on service. The challenge is here that now, let's say, the growing amount of the service, that now we see that undefined processes have to be defined, and that especially engineering engineers are getting new roles and responsibilities. So the complete organization is in a change process. And what I highlighted here, I think I took this bullet as a challenge, but it's also a chance, because we have really the need to change. We must change to grow in the service market, and that's why the complete organization is they're expecting a lot from this implementation, and they are willing to work with us. So this could also be a chance for us. Service is an environment of high uncertainty, as I said. Repair cases are unexpected, and then they are rush orders. We have to deliver them as fast as possible. We have to do more engineering, unknown, different designs from non-ABB manufacturers. Scope is different from order to order, and then after the scope changes mostly after investigation. And if we've done the investigation bad, then it's also the scope changes then while we're doing the repair. The suppliers are fully booked. We have long lead times, and our resources are also used on site. So we have shared resources in the factory and also on site. Of course, from the middle-size companies, we have also a big fight, which means they cannot deliver the complete scope we can, but they are low cost and are faster. The results. So the direction of the MPCC implementation was, so we identify in critical chain a way how we can manage our environment of uncertainties, and we have to focus on internal speed to get our projects done faster. And we are measuring our results on 3 KPIs. The first is the percentage of cycle time reduction. So when we went live in May, we targeted for all projects which aren't, where we haven't started production, haven't started engineering, an internal productivity increase of 25%. So that means for orders which are completed nearly July, August, we saw a potential of 8%. 8% because we are limited by external suppliers and also internal processes. And we achieved for our first projects a cycle time reduction of 4 to 7%, and it's very good. We improved our on-time delivery performance, internally. So we started with 68%, and we achieved 83% of the first 10 of 12 orders which are completed now in Concerto are on time. This is very good results. And the third KPI is the throughput in number of projects, which means here we are comparing the pipeline the pipeline of the first half of the year with the pipeline we had in the end of 2007, and the pipeline of the second half of the year with the pipeline we had in May. And you can see that we have 29% more projects in the pipeline, which means that due to the implementation of MPCC, we were able to meet the aggressive or the big growth plan of ABB, where we have to grow yearly about 30%. The key success factors. I think the first of all is the project core team. Very important, of my opinion, was the external experts. We had AJ for 1 week in Halle, and it was amazing. In just a few days, he understands our complete business, our processes, and we designed the solution. And Travis helps us then in the following 5 weeks to implement this solution, and this was a major key. Then also I think it's important to have internal experts, just not only the one who have the knowledge internally in the rest of the organization. I think it should be also people where the organization is trusting in. So it's typical for German that they don't believe to things from outside, but you can achieve more if it's people from inside. So, and of course the implementation champion, this was our GM, who was in charge of all the departments to force really decisions and to drive the change. And we were reporting to him minimum once a week about decisions to be made. How we've done the WIP reduction. We started in the beginning of 2008 without the software. That means how we did it. Very simple, on a whiteboard where we had all the departments, and we set local WIP targets. It means we implemented a pool system where we have active pools, where we said here is the maximum number of active orders per department. And we had a passive pool where all the waiting tasks were prioritized. And when we finished one in the active pool, then we were allowed to start the next one. But it was important that the full kit was fulfilled. That means that documents or materials were available. Very simple. It's maybe not the best solution. It just should show nothing holds you back from starting with reduction without the software. And the risk is really to when you're doing this, then that you're maintaining local targets, maintaining local dates. So that's why today we're pipelining according our virtual drum. It's the assembly, active part assembly to testing phase, and we're applying for the task managers to put the maximum resources per task, and these local WIP targets we just take today as a cross check. Planning. Let's say we implemented very aggressive planning. That means when we want to achieve a 25% improvement, then we have also to plan so aggressively. We have few tasks, 70, and just 2 milestones in the template. It means milestones, the repair order in, it's after an investigation on customer decision process and the project end. I think the key and our major focus in the solution design was in the buffer management. And this is a sentence I've heard from AJ. Low WIP needs a culture of fast issue resolution and fast execution. That was really the main key. And based on this, we redesigned our execution processes. And we redesigned them how they can be supported by the concerto reports. So we implemented the daily task management processes and the structure in engineering and production. As a base, that was the first step. Then the second step was, after stabilizing the task management process, to implement the management review process. That means we had to redesign our meeting contents, our roles and responsibilities, and also the timely sequence to increase management involvement. And that means that we are focused them on decision making. And that is really the key. This is the decision making for speed up execution. And we're gaining today out of it out of Concerto to have really clear priorities and really early warnings. So in the past, the priorities of the projects aren't clear, and most of the time, project till the project end date, there was a lot of troubleshooting. So from that point of view, to be focused from the beginning of a project was also a major key success factor. Managing non-concerto work. Especially in engineering, we have a lot of work which is not in the system. We have a lot of offer work, and also we have per year about 1,000 smaller field maintenance processes, and they also need engineering, which means to calculate the hours and to order the materials. And this work was not in the system, so we had to find a way how to prioritize them on a weekly sequence. Where we have a big room for improvement is the production support. We haven't found a good solution to filter interruption for the people, that the task managers have the possibility to filter interruptions. So this is something what is still open, so that we have still in engineering, we reduced the bad multitasking, but we have still a big amount there. Because of that, the production is directly calling the engineers and interrupt them from project tasks. So we have to improve here. Which challenges we see? And from the 3 rules, I would say that we have very stable planning process, but buffer management and pipelining here we have to improve. Especially in pipelining, at the moment we haven't done good integrated process with sales, engineering, and project management implemented. The risk is that we are losing control over the pipeline, means that because of the big demand that we are putting more and more WIP into the pipeline, the orders get red, and this pushes so many red tasks, pushes the task managers to start ASAP and to multitask. So here we are trying to implement rules like really just to start like recommended by Concerto as late as possible, or we are trying to control the transformer incoming date based on the pipelining output. So here we have to improve. Today it's more or less in the hand of the planner and the project managers, but also for the duration for engineering and the WIP overall, we need to integrate sales and engineering very fast. In buffer management, we see two main challenges. Task management requires expertise, and especially in engineering, we selected the most experienced ones as task managers because these are the only ones who can really fulfill the requirement of a task manager to prepare tasks, to speed up ongoing tasks, to help their people to speed up execution. But on the other hand, these experts are, in the most cases, the first choice to doing special work. So that means they are the first choice to doing offer work, to doing engineering for repair, because they are experienced since years, and the other engineers which are less experienced, the key is that the task managers have not the capacity to do task management. We have to convince the resource manager really that they should release the task managers from their daily work, that they have the time to train their people, to help them. It's maybe for the short-term view a loss of capacity, of course, but on the long-term view it will be a big improvement. It will be increase the available capacity there. And what we are seeing also is some task managers are trying to operate like before. They are used since 20 years, to working to internal milestones, to very high visible schedules, fixed schedules, to work with Gantt charts. And what we've seen, they are following the priorities of the task list, but they are transferring the task list into Gantt charts because they think these fixed schedules are giving them results, and that means they are not focusing or managing really the aggressive duration. They are not looking forward to be as fast as possible. They always look to have what is the maximum duration I have. So, and this is a big mind shift which needs ongoing communication and capacity coaching. So we have to show them the benefits of being finished earlier, so that they can prepare for next orders, for example. This mind shift is very, very challenging, and I think that a lot of people in this room are knowing what I'm talking about. Okay, thanks for your attention.